Hello everyone, this is Eren Şahin. I'm a sales engineer from liNear. Today's topic is construction and analysis of heating and cooling systems with liNear solutions on Revit. I will use linear desktop heating, analyze cooling, building heating, building cooling dynamic, and building analyze modules in this webinar. If you are working with linear workflow, you only have a few things to do to create your heating and cooling systems. We have already shown you how to detect a Revit building model in our previous webinar. You can easily find it in liNear International YouTube page. After you complete your building detection, you can easily calculate thermal loads of this building. All load calculations will be based on valid standards such as ASHRAE and European norms. Program will direct you and ask for missing parameters for heat loss and cooling load calculations. When you finish inputting parameters, results will be displayed. After that, you can select the desired system to heat or cool your building, and liNear will dimension these systems based on these values and specified presettings. Lastly, radiators and convectors are automatically positioned under the windows, and the floor heating is drawn according to the area plan. Adjustments can be made in model or in the dimensioning process, and all changes are transferred bidirectionally. When the transfer completed, you can easily construct your pipe network and implement components with liNear desktop heating module with automatic routing and connecting commands and extensive product libraries. The pipe network calculations of liNear are directly integrated into the CAD and allows direct access to the construction. Thus, no interface between construction and calculation is required, and no more data exchange problems. The redimensioning can be carried out automatically directly in the model. liNear will hydraulically analyze and balance the heating system according to the boundary conditions that you select, such as maximum velocities and pressure losses, valve authorities, active pipe diameters, and so on. Pipe diameters and pipe network accessories can be selected either generic or manufacturer components. This selection will be used in material list. There is a certain difference in the requirements of a cold pipe network calculation compared to a heating pipe network calculation. In particular, the testing of the use of approved materials and the media data for refrigeration are directly usable advantages. liNear Analyze Cooling is the optimal solution to meet these requirements. It uses liNear desktop heating as the construction model. It means that after you construct your cooling system with liNear building and desktop modules based on ASHRAE standards, you can easily apply your hydraulic analysis with liNear Analyze Cooling. Based on calculation results, you can visualize the system with different parameters such as velocities, temperatures, and nominal diameters, and these results will be displayed on the pipe network. Sixway valves are especially getting used for ceiling heating and cooling systems. It enables various control setups for heating and cooling on one unit. Test results show that it has much benefits such as lowering the pressure losses, and as a result, it gives significant energy savings with pumps. That's why it gets more and more popular worldwide. With liNear Analyze modules, this component can also be calculated within the pipe network calculation. With these valves, you can build your system exactly as in reality with cooling and heating modules. For this purpose, neutral and also manufacturer-specific Sixway valves are available in the liNear product library. The desired valve data can be assigned to the components with the valve preselection dialog. You can choose between valves with and without a flow control, so that sections downstream of the Sixway valve can be detected and calculated by both disciplines. Now let's start to the live demonstration. Here we have a model on the basis of which the heating and cooling loads are calculated. Our calculation results are listed in the linear building software. As we said before, these two interfaces are working interactively. When you change something in CAD, you can easily transfer this change to linear building, and you can do vice versa. In linear building, you can see all cooling loads and heat losses for each room, floor, and the project. Here we also have tabs for radiator, cooling convectors, and panel cooling and heating. Now we will see all details about this. First, let's start with the cooling convectors. When we open this tab, as you see, we have the tree view of our project and we have the cooling convector selection interface. Here we can pre-select the convector that we will use in our project and we will determine the boundary conditions. First, we will select the manufacturer. We can do the selection either neutral or with a real manufacturer. We will select Arbonia. Also, we will select the series to use the exact product that we want to use. After we do the selection, we will click on these arrows and move our selection into this list. If we are going to use two different systems on this list, we can make several selections. Now we will set our boundary conditions for the automatic dimensioning. In VDI options, we can make the selections about pressure levels, surfaces, and connection types. Here we also have dimensioning options. We can set up minimum and maximum dimensions, and also we have different dimensioning options on the right side. You can select considerations based on windows, you can set orientations for length and height, and you can select how should linear behave in case of under or over capacity. And then here, you can select the connection set that you will use for these convectors. Also in here, we can choose our design target and dimensioning presettings. We can select between fixed cooling capacity and the temperature difference will be determined, or temperature difference is fixed and the cooling capacity is determined. And for the fixed cooling capacity, we will select our supply and return water temperatures, minimum and maximum differentials. Also, here we will select minimum and maximum mass flow rates per a convector. Now we will dimension our convectors. We select the second floor. First we will uncheck these two rooms because we will use panel systems with these rooms. And for others, when we click on this command, it will dimension cooling convectors based on parameters that we selected and cooling loads for each room. Now let's check out a room. For example, in this office room, as you see, we have 4 convectors. Its cooling load is 1384 watts, and these convectors are sufficient to cool this room. Each convector has 346 watts of cooling capacity, and for this capacity it has to be in these dimensions at this mass flow rate. And for other rooms, as you see, there are different numbers of convectors are implemented based on our boundary conditions and number of windows. If we check out this log, we will see some errors and warnings for our dimensioning. And as you see, it says that the window width is too small for the selected cooling convector. So it's not aligned with the convector, and we don't have any problem with that. And this one says the minimum mass flow rate for this cooling convector was not reached. And as you see, we have different kinds of warnings and errors for our project, but the dimensioning is already done. Now we will insert these convectors into the CAD model. When we select our floor and click on this command, or we can press F10 on our keyboard, and as you see, it has drawn all the convectors into the CAD. When we insert them, their colors will turn to blue. Now let's check out the CAD model. As you see, all convectors are drawn under Windows. We also have a Radiator tab in here. As you see, the interface for pre-selection is very similar to convectors. Here we can select the manufacturer, or we can use the neutral components. Let's put the neutral component on this list. As you see, this doesn't have any VDI options or dimensioning options because it doesn't have any manufacturer's boundary conditions. So here we will determine the design target and dimensioning presettings such as supply and return water temperature, minimum differential temperature, maximum differential temperature, and minimum and maximum flow rates per radiators. After we do the selections, we can dimension our radiator system too. This one we will dimension for floor 1. When we select the floor and select our general radiator, we can click this 3-dimension command in here. As you see, all radiators are dimensioned based on our design parameters and window dimensions. As you see in this room, it has a heat load of 868 watts and total heat capacity of the radiators is 870. And in here you can see all heat capacities for each radiator's dimensions and the mass flow rate in here. Now we will transfer these radiators to CAD. In order to do this, we select the floor and click on this draw command. As you see in here, all radiators are drawn into CAD file. Let's check out. As you see, our radiators are drawn in here with their parameters. Now let's continue with the panel cooling circuit. In order to do this, we move to the panel cooling tab. First we go to the project. Here we also select the manufacturer first, and then we will move this manufacturer into this list. And let's check out system parameters. As you see, there are different presettings for panel systems. In system parameters, we can select the minimum and maximum pipe spacing. This depends on the manufacturer that you selected. We can also select the maximum circuit length, maximum pressure loss, and coil partitioning, and so on. The selection of coil partitioning will affect the material list. Also, we can select the screen additive and it will be on the material list. We determine the design supply water temperature from here and the differential temperature from here, minimum and maximum values. And in here we can set the valve settings. We can set circuits for only for cooling, mixed mode, or mixed mode heating or cooling prior. And in here we can limit surface temperatures. If surface temperature exceeds this limit, program will notify us to correct this issue from here. Now we will dimension panel cooling systems and insert them into the CAD. We have two rooms that we didn't implement convectors in the second floor. These are two offices. First, we go to the CAD and find these rooms. In order to transfer circuits, we need to create a pipe laying area. We create a view for panel heating and cooling. In Construction tab, there is a command for creating the area plan. After we create this view, we will set the pipe laying area. In order to do this, we use this command. We select the rooms that are going to have the panel system and then click on Escape. As you see, the area is created. Now we go back to the building and find the room. As you see, there are two floors because the floor is adjoining to two different rooms. And now we click here and click on Occupied Zone. As you see, it automatically created three circuits based on cooling load and boundary conditions. Here we have information such as pipe length, pipe spacing, heat capacity, and so on. And now we will transfer these circuits to CAD. We use the same command that we used for convectors and radiators. We select the area first and then the start side. As you see, these three circuits are created. Here in CAD, we can change the pipe spacing. And we select these circuits and then go to this command and change this to 150 and assign the settings. As you see, the pipe spacing is changed. And when we go back to the building and update this, we select the Apply Drawn Pipe Lengths, search New Components in CAD, and we start. Let's go back to the building. As you see, the laying spaces are changed. If you want to change it from here, we select this and it asks, should circuits of the same type have the same pipe lay spacing? We say no, we only want to change this one. And then we click on Update and transfer results to CAD and apply calculated pipe lengths. And when we start it, as you see, we have three different pipe spacing in the CAD. And of course, when we change the spacing, the heat capacity and pipe length will be changed too. As I told earlier in the webinar, we have a Sixway Valve in our product library, and you can use it in your calculations. These symbols represent partial networks. This one is for heating, and this one is for cooling partial network, and the other one is connected to the main pipe network. When we check out their technical data, as you see, this represents 90 degrees of supply water temperature and 70 degrees of return water temperature. And for the other one, we go to cooling discipline. And as you see, supply water 4 degrees and return water 10 degrees of temperatures. And the Sixway valve is connecting these three circuits to the main pipe network. And if we apply calculation, As you see, we have the Sixway Valve in here, and when we click on Edit, you can see the technical data of this Sixway Valve, such as mass flow rate and nominal design diameter. And we can do this calculation also in the heating discipline. And you will still see the Sixway Valve in here with the mass flow rate and nominal design diameter. And now we will continue to our project. We basically constructed the pipe network with all components that we inserted from the liNear building. Now I will show you some of our construction commands. The first one is view control. Here we can easily create views. We select the story that we want to create the view and the discipline, and then we select the type of the view, if it's going to be a 3D view or floor plan or a ceiling plan. And when we click on this green plus sign in here, we have this dialog. In this dialog, we have several options to create this view. When we click on create view, as you see, the view is created and listed right here. And we can switch between different types of view very easily. Now we will continue with the construction tab. This tab shows us construction commands for heating discipline because our view is for heating. We begin with choosing the reference level for our construction. We select the floor and we give the reference, is it the current story or from the next story, and then we enter the value for the height. To start drawing pipes, first we should select the system class. As you see, we have different types of system classes in here, and we select the supply water. And here we have the pipe command. In this dialog, we can select a manufacturer and a system. Also, we can select the diameter and references for the construction. Now we will activate this command and start drawing. Let's make this construction in this part of the system to save time. And yes, we draw our supply water pipe, and now we need a return water pipe too. In order to do this, we can use the parallel pipes command. First, we should set up a configuration. We click on this command. In this dialog, we can set a configuration with pipes or ducts in different disciplines. We can also set distances, pipe diameters, and insulation. Now we will clear this configuration and add return water. After we finish this configuration, we will click on OK. Now we will activate the command and then select the pipe. And we press enter. As you see, it gave us 4 options to draw this configuration. And we navigate between them. As you see, it gives us 4 different options. It can be on the left side, on the right side, or on top, or at the bottom. And when we select one of them, we can click apply, and as you see, the pipe will be drawn. After we create our pipes, we will connect them with components, and for this we will use Connect Components dialog. Inside this dialog, you can set different variations for connections. You can use crossovers, and you can set up distances for X and Y dimensions. And you can set up the angle. You can make an in-wall connection and give value for the insertion depth. After we do the desired selection, we can activate the command and select components that we want to connect. Now let's activate the command and select these components. And click on enter. As you see, all components are connected to the main pipeline. Let's check out this connection in a 3D view. As you see, pipes are connected to the radiator. And here we have the pipe offset command. With this, we can easily resolve collisions. First, let's check out the details. Inside this dialog, we can set distances for X and Y directions. Also, we can set an angle. Another option is if you check this box, the command will use existing fitting to create the offset and you will avoid to use extra fitting. And you can select if you consider insulation or not. Besides, we have 3 modes. You can apply this offset around elements, around linked elements, or manually. We also have a legend command in here. If you want to create a legend, you can easily click on this command and select accessories, fittings, fixtures, equipments that you want to see. You can also select system classes. Here, you can write a headline and configure text styles. In the Arrange and Rename tab, you can change descriptions of materials as you wish. When you click on OK, it will create the legend. In the next tab, we have product libraries. As you see, there are different kinds of components that you can use in heating. These components in here are neutral. They can easily be implemented into the project. When you click on it once, it will be preloaded, and you click on it one more time, it will appear on the crosshair and you can place it anywhere you need to. There's also the liNear CAD browser. When you click on this command in here, it will open, and as you see, there are different manufacturers. For example, if you want to insert a convector or replace the ones in the project, you can enter Purmo and select the convector in here. In here, we can see the preview of this component. Also, there are technical data. You can do your selection between these options, and when you click on Place or Replace All, it will insert it into the model. Here we have a completed model. All pipe network is created and connected with heating and cooling components. Now we will analyze this system. To do this, we move to the Analyze tab. First, we will check out the configuration. In this dialog, you can determine global settings for the pipe network calculation and specify limit values. If you click Help in here, in this page, every parameter is explained. Also, you can get more information about liNear from this Help interface. Now, let's go back to CAD and check this basic condition dialog. This dialog allows you to change basic calculation parameters like specifications for hydraulic balancing, upper limits for maximum speeds, maximum pipe friction pressure gradient, as well as settings for the dimensioning of thermostatic valves, regulating valves, and differential pressure closed loop controllers. It gives you the option for dimensioning. You can consider both maximum velocity and pipe friction pressure, or you can select either one of them. We continue with the product data command. When you select the manufacturer from here, it will be available for the selection of pipe and connection materials. These manufacturers are available additionally to the neutral pipe systems. If you selected a manufacturer provides connection sets, connecting manifolds, and cabinets, these will be applied into your project and they will be in your material list too. In pipe tables, you can specifically select which dimensions that you want to use in your calculations. Here you can change the material and you can insert or delete pipe diameters from this table. With the valves command, you can do a pre-selection for valves that you will use in your system. Data from different manufacturers are available for this purpose. If in valve pre-selection you have selected more than one valve for the same valve type, the most suitable valve will be calculated and automatically inserted. In local assignment, you may select and assign valves that deviate from those selected in global pre-selection. For this example, we selected thermostatic valves to use in radiators. We also have pumps command. If your pipe network contains a pump, its data are initially neutral. The required delivery height and the required flow rate are calculated by the program. And in here, you can select a pump that supplies requirements and it will be used. If a pump in your model has a manufacturer pump assigned, the data of selected manufacturer model will be used for calculation. And now we will calculate the system. The report button is orange. When we check it out, we see that there's a notification report. It says that the proportion of producers is greater than 100%. Producers with a surplus portion are assumed to be redundant. So the dimensioning of the pipes before the producer is based on this assumption. The calculation dialog is here. It has categorized results in 3 titles. These are flow path, section parts, and components. When we select flow path, we can see section parts and components on that flow path. When we expand this dialog, as you see, this row is colored in red. This shows us the critical flow. When you select the flow path and click on Show, it will show this flow path in the CAD model. When you click on Search and select a component or a pipe, it will show you the flow path, the section part, and the component on the list. When we click on Edit, as you see, it will show parameters for the component. It shows the heat capacity, mass flow rate, and the zeta value of this convector. We can also see the connection set and the valve. As you see in here, it shows the kV values for this Oventrop valve. If you click on this edit command and select a component, you can see its technical data. We selected the boiler and it shows the system name, the component's name, and the supply water and return water temperatures for this system. And if you click on the pump, it will show its characteristic curve with delivery height and flow rate. If you select a manufacturer, you can also do it from here and assign it locally to this component. You can click on the catalog as we did before and select a pump based on this curve. When you do this, it will no longer be a neutral pump. It will be a pump with the real manufacturer data. We have a results comment in here. This dialog displays the most important calculation results of the system selected in the calculation dialog. The results of the calculated pipe network are summarized. This can be saved as a text file. It shows details of pipe net, valves, and so on. Also, there is a visualization command. With this command, you can color the pipe network based on selected parameter. These results shown either discrete or continuous. For example, if you select the velocity, click on display, it will show results continuously in a color scale. If we select the nominal diameter, it will color all diameters in different colors. In labeling command, there are labels for each component with some parameters. If we select a convector right here, as you see, there are selected parameters for this label. You can select more parameters if you want to input this data into the component. After you do the selection, you can click on Create Parameter in Network Components command and say yes. All of these parameters will be saved into the components. Now let's select a component, and as you see, all parameters are saved into the component. And here we have one warning. This is the Issues and Tasks tab. As you see, this shows the notification that we already saw in the calculation dialog. In the Output command dialog, you can select titles that you want to see in the output. These are results that we saw in the calculation dialog. And we click on Preview. As you see, we have this report. And this shows us the general data like supply and return water temperature, flow path, section parts and components. And when we move on, we see the compilation of flow path and section parts. And when we continue, we will see the valve settings. It shows all valves that we used in the system. And it shows the circulation pump, heat losses, and from this page it shows us the material list. Now we continue with the cooling system. We go to the cooling discipline and we move to the Analyze tab. As you see, we have almost the same dialog, but there is a certain difference in the requirements of a cold pipe network calculation compared to those of a heating pipe network calculation. In particular, the testing of the use of approved materials and the media data for refrigeration are directly usable advantages. liNear analyzed cooling is the optimal solution to meet these requirements. As you see, we have a medium command in here. And water is selected as a default medium. But if you click on load, you can see that liNear has an extensive range of cooling media. If you select one of them and open it, you can see properties for this medium. And if you want, you can load an external medium file. If you enter your own thermophysical properties and load it in here, liNear will use this data for calculating pipe friction pressure losses. Now let's calculate the cooling system. If we click on this calculation command, it will show you the usual linear calculation dialog with appropriate data. You can see the dimensioning is done based on the basic conditions and nominal diameters that we selected from the pipe table. If you use this edit command and select the cooling tower, you can see supply and return water temperatures, the medium, and the pressure loss. We have come to the end of this webinar. Today, we constructed and analyzed heating and cooling systems on a 3D Revit model. I used liNear desktop heating, analyze cooling, building heating, building cooling dynamic, and building analyze modules in this webinar. If you have any opinions on our webinar or if you have any suggestions for topics that we should cover in our next webinars, please let us know. If you need more information about this subject or liNear, you can reach us via export@linear.eu. If you want to watch this or previous webinars again, you can follow liNear YouTube page. Thank you very much for your participation.